All right. Wrench initially at rest is dropped from a tall building and safely caught in a net when it has a velocity of negative 49.5 meters per second. How far did it fall? So first thing I'm going to do is I am going to draw a diagram. So here is my building. Here is my wrench. There we go, killer wrench there. Okay, and it is falling. So, one of the things we talked about with forces, velocity, all that kind of stuff, is determining which direction is positive and which direction is negative. Now, it told me I have a negative velocity at the end. So the final velocity down here, right before it reaches the ground, right here, that is a negative 49.5. So that tells me that down is the negative direction. Okay. On the final, I'm generally trying to test you on one thing. On this problem, I'm testing on you on can you solve free fall problems. I'm generally not on this kind of a problem trying to test you on can you identify the direction. Because if you made down positive and you made all your numbers positive, that would work out in the end. It would be fine. So in other words, what I'm saying is all your answers would generally be a negative answer because your displacement is going to be down. So you would have a negative value for the displacement.
Do you have to draw the picture?
On the review, yes. On the final, no. Okay. So here are the things that we know. We know that it started at rest, so VI is 0. We know that its final velocity right before it reached the ground was negative 49.5. We know that we're trying to find displacement. We're trying to find how far it falls. Here's the one that a lot of you forgot, okay? And this is just something that you have to know. You have to know that the acceleration for falling objects is always 9.8. Now, that is on the equation sheet. Now, it's not in the 2D, 1D motion section. It's down here in the forces section. And the reason it's in the forces section is so when you do FG, MG, you remember what G is. But this is something we've talked about a lot. A is 9.8, the acceleration. However, acceleration is always down. Okay? So because the acceleration is always down is negative for this problem, so this is a negative 9.8. So I've got VI, VF, D, and A. So I look at my equation sheet, and I'm looking for VI, VF, D, and A. So this is a motion problem, so it's one of these. It is acceleration because it's gravity. So I'm looking at Old Faithful, Big Chalupa, Ain't Got No Time. And I've got VF, VI, A, and D. So VF, VI, A, and T. There are some of you that I saw found time first, and that's totally fine, but that's not your final answer. If you did find time first, you would then need to plug into Big Chalupa to get displacement. Again, totally fine. That's just one extra step than you have to do. VF, not in Big Chalupa, so Big Chalupa's out. Ain't Got No Time, VF, VI, A, and D. So Ain't Got No Time is the one I would use. So VF squared plus, equals VI squared plus 2AD. So 0 squared is 0, so it goes away. Negative 49.5 squared is positive, because remember, when you square a negative, it becomes positive. So 2,450.25. 2 times negative 9.8 is negative 19.6. I've got D here. I want to get D by itself, so I'm dividing the negative 19.6 over. And that gets me a displacement of negative 125.0 meters. Now again, this is a multiple choice problem. So on the final, you would have several different displacement answers. Like I said, my intention would probably be make them all negative, since down is the negative direction. But you do have to be careful on this, on kind of how you make your negatives and that sort of thing. So just be careful on directions, and you should be okay there. Questions on 25? Okay, we'll probably look at more problems next time.